Hey dudes, Dude the Builder here. And this episode of Zig and Death, we're going to be talking about testing in Zig. And in Zig, testing is really easy. It's really straightforward. It's you could say it's natural, which is really a positive aspect of testing in Zig, because usually what happens in software development is that the harder it is to test code, the more steps that you have to go through to configure testing, a testing framework, things like that, then the more likely is that you're not going to do it, or you're going to leave it to the end of a project, or leave it behind in such a way that when you do test, it'll be really, really hard to refactor the code to eliminate bugs that you can discover by testing. And in Zig, that's not the case. In Zig, testing can be integrated right into your development flow, right into the source code, right next to the code that you're going to test. And that's a really powerful concept. And it goes right in line with the reality of developers, that the easier it is, the more likely it is that they're going to actually test the code. Okay? So let's jump right in. Here's a simple add function, okay? And here we have an example of a test for that add function. Now up here, you're going to see that I'm importing stud, the standard library, and immediately I am creating this constant called testing, which is going to be basically an alias for stud testing, okay? And in that testing namespace is where we're going to find lots and lots of useful functions to test our code in Zig, test our assumptions about how our code is supposed to behave. As you can see here, in order to test code in Zig, all we have to do is basically anywhere inside a container. And when I say a container, it could be a struct, enum, a union, or a file at the top level, like we're doing here. Basically, with the test keyword, you provide a string literal, which is going to be a description of your test. And within the curly braces, you're going to put your testing code, which is basically any Zig code that could be placed inside a function. As a matter of fact, if you look at it, it looks kind of like a function. And this would be the body, right? So in here, the thing is that you can make use of all those useful testing functions that we have in the testing namespace. Here we have one of the most simple ones, which is just called expect. And this function takes a boolean, and if the boolean is false, expect will return an error. And since we're using try here, try will just throw that error, propagate it out of the test, and the test framework will treat any error returned from any of the tests as a test failure, okay? So we're just once again seeing how Zig uses the same concepts that you use in your normal source code. These are the same concepts that we're going to use in testing, okay? If a test is going to fail, that's indicated by just returning an error, okay? And these testing functions, like expect, do just that, okay? Here, if the boolean is false, then expect will return an error, okay? Next up, we have another function here, sub. This time we're subtracting. And we have another example of a simple test of that other function, okay? Once again, we're using expect here, okay? Now, we're going to see an example of a struct that has these 4 fields, and each of these fields are of different types. We have a bool, we have a u8, we have a slice of const usize, and a slice of const u8, which would basically be a string. And here we have a new function that will return a different version of this foo struct, depending on the flag that we pass here, which is a bool, okay? If it's true, we're going to return a foo with these values. If it's false, we're going to return a foo with these other values, okay? And here we have an example. As I said, you can have tests inside basically any type of container. A struct is indeed a container, so we can have a test in here. We're just doing an expect true here, okay? Now, what we're going to see is we're going to see a series of tests that we're going to do with the different functions that we have at our disposal from the testing namespace. First, we create an instance of foo, passing in true, okay? And then, with the normal expect, we test the first field, which is indeed a Boolean. Then, we have expect equal, and expect equal has 2 parameters, and it'll just test these 2 parameters to see if they're equal. If they're not, it'll return an error, okay? So here we're using the as built-in, because we're going to be using a literal 1 here, and we want that 1 to be a U8 because that's a type of this B field of foo, okay? And we want the types to match because we're testing for equality. Here, we're using this other expect variant, which is expect slice equal slices, okay? And it allows you to compare 2 slices to see if they are indeed equal. And here we have another one, expect equal strings, which will do the same. It will test this string, which we're expecting, with whatever we're trying to test here, which is the D field of foo, okay? Next up, we're going to see an example of how you can even test for an error, a specific error. Here we're defining a simple little error set that has just one error called boon. Here we have a function, harmless, that basically returns the error union, error, or void. And what we're doing is only exclusively returning that error, boon. And here we have an example of how to test. Okay, we have an expect error function. And in this case, we specify the type of error here using the literal shortcut syntax that we saw when we talked about errors, error.boon. And we call the function here. It's important that you don't put the try here, because if you put the try here, what it will do, if it has an error, it'll propagate the error and it won't let the expect error function do its job. We want the actual error union to be returned, and then expect error will indeed have the chance to check that the error union is equal to this error that we're trying to test here. Okay, so let's go to our other terminal and let's run. In this case, the command you would use to run the test would be sig build test. Okay. If we do this, and all tests are passing, you see that there's no output. And this is maybe a little confusing for new users, but when you get no output, that means that everything passed. If you'd like a little more information, you can do -- summary all. And there you go. Now we have a little more information. It says 3 out of 3 steps succeeded. Let's clear the screen. Let's go back here and let's take a look at what happens when we have some failing tests. Okay, see how that output looks. So what we're going to do here is we're going to create the other type of foo. Okay, and now I have an alias zbt that does the sig build test summary all. And when we run the tests, we see that this test, our expect with the foo.a is failing, okay? Because now foo.a is going to be false, okay? Now what we're going to do, we're going to comment that test out and see what the next test produces. Here we have an example of how when we have test expect equal, it'll tell you here in this, pretty much the first line, it says expected 1, found 0, okay? And once again, it'll point to our test here, expect equal as U81 foo.b. Okay? So let's clear the screen. Let's comment out that test. Let's look at the next one. Here we see that when we use expect equal slices, we get a detailed output here with what it's expecting. It's expecting index 0 to be 1, index 1 to be 2, index 2 to be 3. And what we got is index 0, 4, index 1, 5, index 2, 6. Okay? And once again, we can see here where exactly which one of our tests is the one that fails. Okay? Let's comment out the next one and see what we get now with expect equal strings. Once again, you will get pretty much a detailed description of what happened. Okay, here it's saying that we were expecting hello and we got bye, and then it tells you exactly where the first difference occurs. Here we have the H. It gives you the ASCII code here, and the first difference is indeed the first character. Here it's a B, so we have this ASCII code here. And once again, we can see the line where the test failed. Okay, so as you can see, these different test functions allow us to have some useful information of what's failing in the case of a test failure. And let's run this once again. And now, as you can see, we have 5 out of 5 tests passed. Okay. Now, one other thing I wanted to demonstrate is I have another file here. This file is called arithmetic.zig. We pretty much have the same functions with a couple of tests here, the add and the sub. Okay. And if I go back here to main, I could, if I do const arithmetic equals at import arithmetic.zig. Okay. I save this. As you can see here, right now we have 5 out of 5 tests passing. If I run this again, we still have 5 out of 5 tests passing. Okay, so these two tests from arithmetic.zig, even though I'm importing this file over here in main, they're not being run. Okay, because basically they're not referenced. They have to be referenced so the test runner will actually run them. And what we can do in that case is we can have a test block without a name. Open the curly, close here, and we can just have this assignment, basically a discard assignment here with a special identifier underscore. And this will basically tell the test runner, hey, we have a test here, and we're importing this file, so you should check inside this file to see if there are any tests. And now, if we run here, or sig build test, you're going to see that now we have 8 out of 8 tests passing. Okay, so in this other file, we have 2 more tests, and this test block itself also counts, so that would be 3 more. So we had 5 plus 3, now we have 8. Okay, so that's how you can from your primary entry point file, in this case main.zig, you can add this kind of block if you want to tests run the tests in other files. Okay, and when we had here, let's go down here to this struct foo. Remember, we had this internal test here inside of foo. This is indeed being run because in this block here we are referencing foo. We're using creating here an instance. If I were to comment this block out, this means if we were only eliminating this test, then we should have 7 out of 8 7 tests instead of 8. So let's check that out. And as you can see now, we have 6 out of 8. So what happened here is, since we're no longer referencing foo from anywhere, well, then this test isn't run either. Okay. So as you can see, you have to, much like functions that aren't used, they're not even evaluated. Well, it happens pretty much the same with tests. Okay, if it's not referenced from anywhere, it's not going to run. Okay. If I once again uncomment that, now we're back to 8 tests. Okay. And one other thing I wanted to demonstrate is how you can filter tests. And for that, we can use here, I have the build.zig, okay? And if in the normal build.zig, in both executable and library projects, you're going to find this main tests block, constant being defined using the function add test. We have the source file and target and the optimization. And I have this commented out here. So let's uncomment that, and you can add or set the field filter, okay, of that instance called main tests. And right now it's an empty string, so we get exactly no filtering. Okay, but that string is basically, it's kind of like a regular expression, but whatever you put here, any test that has that in its name is the only tests that are going to be run. So for example, we have some tests that say basic, that have basic in their name. So now if we run the tests, we're going to see that now we only have 5 out of 5. Okay, so that indeed is filtering. Now you could use this mechanism also, maybe creating like a marker. Let's say here, pick me, just to ensure that only a specific test will run. Let's see, let's add this here to the test name, pick me. Okay. Now let's run the tests and see. There you go. We only have, it says 2 out of 2. And it says 2 out of 2 because it's taking into consideration this block here, which has no name. When you have blocks, test blocks without a name, they will always be run. There's no way to filter them out, okay? But even so, it's not running any of the tests in this file because they're not matching the filter, okay? Now, let's eliminate that. Let's comment this out once again. And let me show you one last thing, is that within a specific test itself, you can also make the test runner skip the test simply by returning, you can say here, return error dot skip zig test. Okay? Since this is a return statement, we're getting the error of reachable code. This code will not be reachable, and that's not allowed in Zig. So you can put this behind this true. Now, if we run the tests, we see that now we have 7 out of 8 tests passing, and it says 1 skipped. Okay, so when you use this mechanism, it'll be reported as a skip tests. As a skip test here, once again, 7 passed, 1 skipped. Okay, so that's another mechanism. You could, for example, at the root level of the file, have a variable, for example, const skip flag equals true, and then you could use that, for example, with an OR condition logical operator. So you can do if skip flag or here, secure screen, run the tests. Now we see once again we have 8 out of 8. Okay, And now, by just changing this to false, we run the test again. Now we get 7 out of 8, 1 skipped. Okay, so that's an alternative that you could use. You could establish a flag like this, and then in your tests do these types of conditionals to basically have a mechanism where you can activate and deactivate tests. Okay. So as you can see, testing in Zig, once again, it uses pretty much what you already know from the language. We're using just errors, we're using try, we're using simple blocks here. And this ease of use and being so straightforward will allow you to easily test your code without much hassle. And thus will improve the likelihood that you will do testing. So I hope this is useful. Dude the Builder here. See you in the next one.